So let's define some terms and responsibilities. Using this, using this picture, we're just going to walk through what all of these different terms are. So an antenna is the interface between radio waves propagating through space and electric currents moving in metal conductors used with a transmitter or receiver. So on both sides, there's this antenna on the ground. There's an antenna in space, this little dish, this large dish. In transmission, a radio transmitter supplies an electric current to the antenna's terminals, and the antenna radiates the energy from the current as electromagnetic waves or radio waves. And you can see that going in an uplink and downlink. The uplink signal is this blue, and the orange signal, downlink. They are both transmitted in electromagnetic waves, where the zeros and ones are encoded in the wave itself. In reception, an antenna intercepts some of the power of a radio wave in order to produce an electric current at its terminals that is applied to a receiver to be amplified. Antennas are essential components of all radio equipment. Let's talk about a transceiver next. So a transceiver is a device that is able to both transmit and receive information through a transmission medium. It is a combination of a transmitter and receiver, hence the name transceiver. There is a transceiver, likely on the satellite itself, that is producing these ones and zeros and also taking in ones and zeros. On the ground station, that's likely the case too, but we're not going to focus on that side. We're just going to focus on the spacecraft side. The RF signal, where RF is radio frequency. Radio frequency is the oscillation rate of an alternating electric current or voltage, or of a magnetic, electric, or electromagnetic field or mechanical system in the frequency range from about 20 kilohertz to 300 gigahertz. This is roughly between the upper limit of audio frequencies and the lower limit of infrared frequencies. These are the frequencies at which energy from an oscillating current can radiate off a conductor into space as radio waves. Different sources specify different upper and lower bounds for the frequency range. Energy from RF currents and conductors can radiate into space as electromagnetic waves or radio waves. These signals have parameters such as frequency, phase, and power intensity of signal or transmitting power. The communication link is a communication channel that connects two or more devices for the purpose of data transmission. The link may be a dedicated physical link, or in our case, it's a virtual circuit that uses one or more physical links or shares a physical link with other telecommunication links. We have here a point-to-point link. It's a dedicated link that connects exactly two communication facilities, so two nodes of a network or a radio path between 2 points. We talked about the uplink going from ground to space, and the downlink is going from space to ground.